Welcome to the Namecoin lecture. So Namecoin is it's a blockchain. It's an independent blockchain. It's the first Bitcoin fork that aims to provide a service which is similar to the DNS system. So it's called the domain name system. So the domain name system does the following, right? So when you have a name like bitcoin.org is a domain, right? So you have this is a TLD, a top level domain, and there you have a domain name that's associated to this one that somebody registered, and this points to an IP address which your browser will look up, because only then your browser can fetch the content that is at this web address, right? So this is the domain name system, and so Namecoin basically wants to provide the same service, so anyone should be able to register a name. The difference to the DNS system, which is run by 13 root servers, so these are centralized root servers. The difference here to Namecoin is that it should be decentralized such that there's no trusted third party. That's the goal. Now, it's an extension to Bitcoin, where the Bitcoin script language is extended. This means there are 3 new opcodes that have been added, namely name new, name first update, and name update. And if you look at a timeline, we're gonna look at now how to register a Namecoin domain name. So let's assume you want to register this particular domain name, right? Then what you do is you issue a transaction. So here this is at this point in time you issue a transaction that contains the opcode name new, and it contains the data blob, which is the hash of a random nonce that is not broadcasted, right? The random nonce itself is not visible to anyone. So you take the hash of this random nonce and the domain name that you want to reserve. Then at some later point in time you issue a second transaction with the opcode name first update. Here you include the random nonce in clear, so this is visible, right? You include the domain name and you include the IP address, right? Such that this domain name will point towards this IP address if you want to resolve this in your browser, for instance. And finally, if you want to update the IP address, so here we had the IP address .23. If you want to update it to .24, then you can issue a new transaction, which uses the Bitcoin opcode, script opcode name update. It again contains the random nonce, the domain name, and the IP address. Right? So now, what do you think? Why do you think? So think for yourself. Why should we use name new? Right? Why should we use this particular opcode? And why can't we just issue an update right away? Right? So pause the video for a few seconds and think to yourself: why should we do this here? What is the rationale behind doing so? Okay, so I hope you had some thoughts of this. So if you consider that this data here, this domain name will be public, right? Then technically somebody could front run your update request. So you need to have here a certain amount of confirmations, of block confirmations of the blockchain, because otherwise, if you see this transaction being broadcasted on the network with this domain name, you could just issue the same transaction and effectively try to front run this domain. So what we have here, it's a commit and reveal scheme, where you commit to a domain name, right? Like the cryptographic hash here allows you to commit to that. And at a later point in time, you reveal it, right? And this allows you to not be front run by some other adversaries that want to snap your domain. Very good. So this is basically how you use Namecoin, or how Namecoin was used. So you can see here these are the three opcodes, and each of them they cost some Namecoin coins. So this is the currency that's being used on this blockchain, and it's really just a very application specific blockchain that contains that only does this, right? Registering new names. So people have run this experiment. I mean, the Namecoin was actually a blockchain that was running, and the thing that we have seen that happens is that so this was studied here at Vice in 2015, is that the number of names claimed belong, so a large fraction of the number of names claimed belong to quite a few percent of the Namecoin registrations, right? So this means we basically have a few squatters here. These are people that probably have used some kind of a dictionary to register as many domains as possible, because they thought, well, later I will have the opportunity to sell them at a higher price. And this is just the same as nowadays people are registering domain names but not effectively using them, to just keep them dormant until there is some interested buyer. And this brings us to bad incentive structures. So it's not that trivial to build proper incentive structures for these decentralized and distributed systems, where you have a price dynamic. It might change. You don't really know you don't really know how the price is going to evolve, what people are looking out for. So it's interesting to see these experiments happen in real life. So what does this, like conceptually speaking, what does this show us? So if you want to add new functionality to Bitcoin, right, we kind of have to extend the script language. So in Namecoin, as we've just seen, right, we want to add some data to a global state, and that's registering a name. So that's a global state data that everybody should see. We can do so by proposing new opcodes, right? And we also have to keep in mind the incentive structures. So there will be some, or there are some fees for registration to limit squatting, and also to limit expiry if a domain name expires. So it needs to be updated every few years or so. And the same goes for other systems. So Open Bazaar is, for example, a marketplace, right? So you want to have a global state that represents merchants, ask and bid prices. So you need to add the corresponding opcodes such that your blockchain can perform these operations. And then obviously you have transaction fees for trades that goes to for example the system, those that are mining the blocks in order to avoid spam, etc. Okay, so if you look at even a more higher level, right, as you know, Bitcoin is a unspent transaction output based blockchain. So you have this UTXO, right? You have a transaction with an input on the left side, and then one or several outputs on the right side. So here's 1 to n inputs and 1 to n outputs. So in the set of UTXO here that are not yet spent, so unspent transaction output, this is the global state. This represents the global current state of the Bitcoin blockchain, right? The opcodes are executed within transactions, right? This is the data that you where you have, if you here have a second transaction, you take the data, the opcodes from here. You can take the opcodes from here, and then you evaluate whether the script here matches true. And transaction fees in Bitcoin are paid based on the size of the transaction. So the size in terms of bytes of the transaction avoids spam. So the bigger the transaction, the higher the price in terms of Satoshi that needs to be paid.